welcome back to our channel Competition Wars. Today, we are going to explore one of the most futuristic communication technologies ever created, which is Wi-Fi. Imagine getting ultra-fast internet, not from radio waves, but directly from the light bulb above your head. Sounds unbelievable, right? In this presentation, we will understand how Wi-Fi works, why it could revolutionize wireless communication, and where it is already being used in the real world. Today, billions of devices like smartphones, laptops, smart TVs, and smart watches depend on Wi Fi. All these devices share the same radio frequency spectrum. As the number of connected devices increases, the wireless spectrum becomes overcrowded. This leads to slower internet speeds, high latency, signal congestion, and interference. Experts believe that the current Wi-Fi system is approaching its capacity limits, creating the need for a completely new communication technology. Wi-Fi stands for Light Fidelity. It is a wireless communication technology that uses LED light instead of radio waves to transmit internet data. This technology was introduced by Professor Harald Haas. Wi-Fi can deliver extremely high data speeds, better security, low latency, and improved energy efficiency. Unlike Wi-Fi uses visible light communication, making it one of the most advanced technologies for future networking systems. Massive bandwidth advantage. One of the biggest advantages of Wi-Fi is its bandwidth availability. The visible light spectrum is more than 10,000 times larger than the frequency spectrum used by traditional Wi-Fi. This means Wi-Fi can support a massive number of devices without congestion. By shifting communication from crowded radio waves to visible light, Wi-Fi opens the door for ultra-fast downloads, stable communication, and improved network performance. Let's move on to know about the basic working principle. Let us understand how Wi-Fi actually works. First, internet data enters the LED driver circuits. The driver converts digital binary data into rapid electrical pulses. These pulses make the LED bulb flicker billions of times per second. Even though the flickering is invisible to the human eye, it carries internet data through light waves. A photodiode receiver captures these light signals and converts them back into digital data that devices and laptops and smartphones can understand. Now, the two major components of Wi-Fi are the LED bulb and the photodiode. The LED bulb acts as a transmitter. It rapidly changes light intensity to send the digital information. The photodiode acts as a receiver. It detects tiny changes in light intensity and converts them into electrical signals. Together, these components create a complete wireless communication system using light. Now, let's understand how Wi-Fi will be used in the real life with some scenarios. Moving on to the scenario 1. It is related to secure officers. One major application of Wi-Fi is in secure corporate offices and government meeting rooms. Traditional Wi-Fi signals can pass through walls, allowing hackers to intercept sensitive information from outside the room. Wi-Fi solves this problem because light cannot penetrate walls or closed doors. This creates a physically secure communication environment. If someone cannot see the light secure, they cannot access the data being transmitted. For example, if they are talking about the most confidential financial data, they can make it more and more confidential when they use this Wi-Fi technology instead of Wi-Fi. Moving on to the scenario 2, it deals with the gas refineries. Wi-Fi is also extremely useful in hazardous industrial environments such as gas refineries, petrochemical plants, and mining areas. In these places, even a tiny electrical spark from radio frequency communication equipment could cause explosions. Since Wi-Fi uses light instead of radio waves, it eliminates electromagnetic interference and reduces ignition risks. This makes it a much safer communication technology for dangerous environments. Moving on to the scenario 3, it deals with the smart intersections. Another exciting application of Wi-Fi is in autonomous vehicles and smart transportation systems. Self-driving cars require real-time communication with traffic infrastructure. Traditional wireless networks can experience delays during heavy congestion, but Wi-Fi enabled traffic lights can directly transmit data to vehicles using light beams. This provides near zero latency communication, allowing faster reaction and improved road safety. When we compare the Wi-Fi and Li-Fi, the Wi-Fi uses radio waves with Wi-Fi uses visible and near IR light. Moving on to the interference, Wi-Fi has a higher interference with metal and other RF signals, but Wi-Fi is with zero electromagnetic interference and optical paths. Moving on to the data security, Wi-Fi offers low data security, but Wi-Fi offers high data security contained by walls. And moving to the physical range, Wi-Fi is roughly around 30 meters and Wi-Fi is around 10 meters of code. And the real world advantage of this is high localized density and cell division. Moving on to the limitations of Wi-Fi. Although Wi-Fi is highly advanced, it still has several limitations. First, it requires direct line of sight communication, meaning obstacles can block the signal. Second, Wi-Fi cannot penetrate through walls, limiting coverage to a single room. Bright sunlight and ambient lighting can also interfere with communication outdoors. Additionally, Wi-Fi requires special receiver hardware such as photodiodes. Because of these limitations, Wi-Fi is currently considered a complementary technology rather than a complete replacement for Wi-Fi. The future of Wi-Fi is extremely promising. Researchers believe that Wi-Fi and Wi-Fi will work together to create a powerful hybrid communication systems. Wi-Fi could play a major role in smart homes, hospitals, military communication, airplanes, underwater communication, and smart city infrastructure. In the future, every LED light source around us could potentially become a high-speed wireless internet transmitter. To conclude, Wi-Fi represents a next generation of wireless communication technology and offers ultra-fast internet speeds, enhanced security, low latency, and improved energy efficiency. Although there are still challenges to overcome, Wi-Fi has the potential to revolutionize the way we connect and communicate in the future. From secure offices to autonomous vehicles, Wi-Fi could soon become an important part of our daily life. Thank you everyone for your attention. I hope this helped you understand the exciting future of Wi-Fi technology and its impact on wireless communication systems. If you have enjoyed this video, please support the competition buzz by liking, sharing and subscribing for more future technology content. Thank you once again.